This is functions number 1, packet number 10, inverse functions. So we're going to use store to evaluate our function f and our function g. So f of 5 is 11. We do g of 11, so let's store 11, plug it into our function g. It equals 5. If we store 0 in function f, we get 7/2. If we store 7/2, we end up getting 0. If you store -3 into f, we get -1. If you store -1, you'll see you get -3. You should see a pattern start to arising here. So if we calculate f of g of 5, first do g of 5, store 5 for x, plug it into your function g, it equals 1. So now we're going to take that output value and make it our input for function f. And so we store 1 to function f, and we get 5. So you see a pattern. Our input for function g became our output for function f. So without calculation, we could determine the same f of g of pi. We have g of pi. It's going to give us a value, and then whatever that value would happen to be, we're going to plug it into function f. And remember, the input for function g becomes the output for function f. So the two functions seen in exercise 1 are inverses because they literally undo one another. The general idea of inverses is shown below in the mapping diagram. We have the domain of f and the range of f. The domain of f becomes the range of g, and the range of f becomes a domain of g. So your domain and change are going to be interchange. So the x and y in your original becomes interchanged y and x in your inverse function. So if the point -3, 5 is your original function, when you do the inverse, we interchange domain and range, interchange our x and y values. It becomes 5, -3. So it's choice 3. All right, using our graph, we're going to evaluate 2 on our inverse and -4 on the inverse using the graph given. So f inverse at 2 means our x was equal to 2. What was our y equal to? So if that's for the inverse, that means in the original, we don't know what the x is equal to, but we know the y was equal to 2 because it's the x value for my inverse, so was the y value for my original. And I need to erase this. That does not belong there. So let's go to our graph, which is a graph of the original function, not the inverse. And let's see where y equals 2 on our graph. So here is where y equals 2. So we're going to draw a horizontal line at that value of y equals 2. And we see that point is 6, 2. So our value for x was 6 in our original. That becomes our value for y in the inverse. Now let's do the inverse of f at x equals -4. So we want to find out what is y equal to. So that means in our original, we don't know what x equal to, but we know y was equal to -4. So again, let's go over my y is equal to -4 on my original, which is right there. Let's draw my line. Y equals -4, and that's the point there, which is -3, -4. So when y equals -4, my x was -3, so my y for the original was -3. So for part B, the y-intercept of the inverse, which means that's the x-intercept of my original. So the x-intercept of my original is the point 3, 0, which means if the original x-intercept is 3, 0, for my inverse, that makes the y-intercept 0, 3. Okay, they want us to graph the inverse. Well, to graph an inverse, we're going to interchange our x and y values. So we know one point on that graph is 0, 3. We also know if the point -3, -4 was my original, on my inverse I can graph -4, -3, and the other point, which was 6, 2, we can now interchange and graph 2, 6. So let's plot those points. -4, -3. So -4, -3. We can graph 2, 6. And then we graph the point 0, 3. Using our straight edge, we can graph this line. Oops. So we'll call this our inverse function, and the edge of the original one was just our function. Okay, there's a table of values for our original function. So in the inverse, we interchange our x and y, so we just switch the ordered pairs. So it's 4, -2, it's 1, -1, it's 0, 0, 1, 1, and 4, 2. So let's graph and plot these points. So I've got 4, -2, I've got 1, -1, 0, 0, 1, 1, and 4, 2, as best as you can. Okay, so draw your graph. And what you notice about the graph of the inverse, it does not pass the vertical line test. So therefore, it's not a function. So knowing that the inverse did not pass the vertical line test, if the original function doesn't pass a horizontal line test, its inverse will not be a function. So for a function to have an inverse, it's a one-to-one function, which we've done before. So we can apply that horizontal line test to the original function. If it doesn't pass the horizontal line test, it is not a one-to-one function, and the inverse will not be a function. So to determine which of these does not have an inverse, you'd put them all in your calculator and see which does not pass the horizontal line test. And when you put choice 4 into Y1, you'll see that the graph looks like that. So when you draw a horizontal line, you'll see it may be a function, but it's not a one-to-one function.